Hello everybody, welcome back to another video. Today we're going to be doing an analysis of Kobe Bryant's shots with Python. If some of you aren't familiar with Kobe Bryant, he was one of the greatest players of all time. Here's some footage to back that up.
Running in the house for 12 o'clock. Yeah, the hood love me, but you gotta watch. Amen. I just popped 3, I don't do sleep. Yeah, tryna shoot a scene, make a movie. Yeah, we gon' fall through, coming through deep.
He's gonna score.
Alright, so the goal of today's video is to use matplotlib, pandas, and numpy to create a shot chart that looks something like this. So let's get right into it. Let's not waste any more time. Right into the code. So obviously we need to import some dependencies here. Our libraries, panda, numpy, and matplotlib. We're only going to be using pyplot today. So these are all the imports we need. Now the data I already have in my Kaggle notebook set up here, and I will leave a download link to the CSV so you guys can download that on your computer and upload it to Kaggle or whatever IDE you're using. I just like Kaggle because everything's really simple and convenient. Alright, now we need to import our data, and the way we do this is data equals pd.read_csv, just like the previous video we did with logistic regression. Make sure to check that out. We need to copy the file path, so we simply go to the side over here, copy the file path, paste it in here, and there we go. We have access to our data, and to prove that, we'll do data.head. And as we can see, we are able to see all of our columns and the entries within those columns. Okay, so to make a shot chart, we need to know a couple of things. Where the shots were made, so the zones or the areas that the shots were made, whether the shots were made or missed, and the X and Y location of those shots. I want to focus on whether the shots were made or missed for now. Let's look at the data column shot made flag, because that's really going to be the column that is the most important. It's a binary output of 0, 1, whether the shot was made or missed. And this is a log of all of Kobe Bryant's shots in his entire career. So if we print this out, we're going to see that some of the entries have this letter NaN, which means there's no entry in that row. It's an empty row. So what we need to do is use numpy to be able to take all the empty entries and remove them from our data set because they're not going to be useful, right? So the way we do this is we say data.drop_NA, where we need to define our subset, which is essentially our column, and we can define it like this: shot made flag, just the name of our column. And then in place equals true allows us to perform this operation. Okay. Now to verify that what we actually did something to the dataset, removed all the entries, we'll print again this column and see how it changed. Okay. So now we print this column, and we can clearly see that there are no empty entries, which is great. That's exactly what the purpose of our code was, to create a column with no empty entries so we could actually use this in our data analysis. All right, so now the next step is we need it to plot missed and made shots differently, because we want to make a plot that's going to show us what shots Kobe missed and what shots Kobe made in a colorful and visual way. So let's get to that. The way we can do this is with a for I in range statement and a conditional. And I'll get into actually how that works right now. So for I in range, we're iterating through our data set, so we can really iterate through any column we want. But I prefer to iterate through a column I know I'm going to use. So let's iterate through the column data.locx. That's the x position column, and we're going to be using that in just a second to actually do our shot chart. So this is what our conditional needs to be. We need to say if the shot was made. So if the entry in a certain row of shot made flag equals to 1, this is how we write that. If data shot made flag dot iloc, we can't just call the indice because it's a panda data frame, at indice I equals, if that equals 1.0, then we plot a green point on the graph. Now, made shots are going to be denoted as green circles, and missed shots are going to be denoted as X, red X's. All right. So we're going to do plt dot plot. Now we need to plot the X position, so we can say data brackets loc X, and the same for the Y, data brackets loc Y. Now here are some important things that we need to add. We need to add the specific indice, because then we're just going to have a plot of every single data point. We need a specific indice here and also in the Y. So what we've done so far is we've plotted, this code so far plots every point that was made, but it doesn't account for the formatting and the color that we wanted to add. All right, so the first thing is we're going to say color equals green. Very self-explanatory. Color equals G. And then if we want our marker to be circular, or a point to be circular, we say marker equals O. And that's how our marker is going to be circular. Now, that's if the if statement is true, if the conditional is true. If it's false, so if we have an else statement, then we can literally copy this line, but we're going to just do one thing differently. All right. We are going to change the color to red, and we're going to change the marker to X. Okay. So if the shot is not made, if it does not equal 1, then X. All right. Let's set a specific figure size. This is just for formatting. You can set the figure size to whatever you want. I suggest you fit it, just write what I have down, and then you can play with it a little bit later. All right. A couple last things. We want to limit certain X and Y values that we don't really need to display. Negative 250 to 250, and you'll see exactly why in a minute. And our Y values to 422.5, negative 47.5. And now let's show our plot. Let's see what we have here. Okay, so here is our graph, and this is pretty cool. We can see every shot that Kobe has taken in his entire career plotted on one graph. That is the power of data. Now, one thing that's a little misleading about this graph, because green is a little bit more dark and kind of bright in certain areas, and the same for red, it looks like Kobe made a lot more shots from a certain area, which might not be true just because of the color scheme. So let's make these data points a little bit more transparent so we can actually see what's going on with all the data points. So we'll use another argument called alpha, which denotes the transparency of the point. And let's set it to 0.4 and see how our graph changes. All right, so let's recompile this code and see how the graph changes. It might take a minute. Let's see how it changes. Okay, so now that we changed the transparency, this graph looks a little bit better. We can see the full range of data points on our graph, and it looks like we've gotten a pretty good representation of Kobe's shots on a plot. But I want to take it one step further. There is a column in our data set called shot zone area. I want to show you that. All right, here it is. If you can see it, I'm highlighting it, shot zone area. There are 5 different shot zone areas. Actually 6, including the backcourt. I'll talk about that in a minute. So 6 shot zone areas. Right side, left side, center, right side, center, and center. And then there's the backcourt, which are those half court shots. What I want to try to do is segment the shots into those shot zone areas and represent for each area what percent did Kobe shoot from each area. So did he shoot 50%, for example, from the right side and 40% from the left side, to map where Kobe was most effective with his shots. All right, so let's make a new cell and let's get right into it. All right, so the first thing we have to do is create some kind of like group variable that we can call on to iterate through the different groups that we have, the different shot zone areas we have. So we'll create a variable called area groups. And the way we can iterate through the different groups or areas in our shot zone area variable is by calling on data.groupBy and then saying the name of the column, shot zone area. All right. Now for each area, we want to denote it with a different color. So we can make a list of colors. Now Matplotlib accepts a certain amount of colors that use individual letters, and then there are alternative colors that you have to use big fancy words to define. So I'm just going to use the colors that are singular letters so we can easily iterate through a list of those colors and assign each area one of those colors. So the way we do this is we just say list, and then we have this string of characters, blue, green, red, cyan, and so on. All right. Now, let's get to the fun part. We need to know the accuracy within each shot zone area. And the way we're going to do this is we're going to calculate the accuracy for each area, append it to a list, and then individually call on those accuracies when we need them. So we need to make a variable called accuracy list. All right, and we'll come back to this in just a minute. All right. Now what we actually need to do is iterate through the areas, like I said. So we are going to write a for loop that iterates through the different areas. So we're going to say for I in area, and this is the structure we need because this is what the data looks like. Like this is the formatting of the column. For I area in enumerate, we're numbering the area group. So we're adding a second column in the area group's data type. So for I area and enumerate area groups, because we have the number, which is this, and the area itself. So for I in the number and the area, the numbered area, this is what we're going to do. We're going to create a scatter plot. All right, a mini scatter plot of our area. So how do we make this mini scatter plot? We say area because we can actually call on the shot zone area. Lock x, the x values of the area, the y values of the area. Oops. Area, y values. And then to assign an individual color, we say color equals colors. That's the name of our variable right here. And we need to call in an indice within this variable. So colors at indice I. And we'll use the transparency again just for fun. And we'll set it to we said 0.4 before. We'll set it to 0.1 now so you guys can see the difference in transparency. Now we need to calculate the accuracy, Kobe's shot accuracy from that given area. The way we do this, we create an accuracy variable. So we create an accuracy variable. Now let's think about how we might calculate accuracy using our area. So how might we calculate accuracy using our area? So the area has the shot made flag column, right? Because the area has all the columns of our data set. So we can actually say area with our indices shot made flag and take the sum of all the entries of shot made flag. So dot sum. And then what we can do is divide that by the amount of entries, by the length of this. So we can literally just copy it in. Forgot a bracket. All right, so by the length of that. All right, that's the accuracy. All the entries divided by the length of the area. All right, now what we can do is we can say accuracy list, because that's the list of all the accuracies from the different areas, dot append accuracy. And now we have a list of all the accuracies that we can call on in the future. So we've done all the work. We've plotted each area, we've assigned each area a different color, we've calculated the accuracy of the area. Now all that's left is to literally just plot this. So first, what we want to do is let's just print the accuracy list and make sure our code works before we actually get into the plotting. So let's just print our accuracy list. All right, so this is what our plot looks like right now. It doesn't look amazing. I'll tell you why. Because of our formatting, we didn't include this line plot figure equals fig size 12 by 11. So let's add that, and it's going to look exactly like our previous plot. So let's just add this. And now our plot is going to look a lot better. All right. And then we need to also add the limits that we used previously. So these x limits and y limits, let's just copy those in. And our plot should look a lot better. There we go. So our plot looks the same, and this is all the shot areas. This looks pretty cool. You see that each area is denoted by a different color, and all we have left to do is just take these accuracies that we have here and actually plot them. All right. So now our job is to say, okay, where does each accuracy go? All right, so this first accuracy is the backcourt accuracy. The next accuracy is the left, and the left, which is denoted by the blue, and then the left center, which is the red, green center, and right. All right, so we're going to place all those accuracies in their given spots. So I actually did this in advance. I found the coordinates for each a place where we need to place the percentage of the shots made in each area, so you wouldn't have to. So the way we actually plot text on a graph is we literally just say plot.text, and then let's go through the coordinates of each accuracy. So the accuracies right now are actually decimals lower than 1, and we want them to be numbers between 0 and 100, so we have to just multiply all the accuracies by 100, and that should yield, oh, I forgot to put an argument here. That should yield, that should yield numbers between 0 and 100, which it does. Great. So now what we have to do is plot the accuracies where the shot zone areas are. So the first one is the backcourt. So the backcourt's coordinates are -10, 400. And the way we call on our accuracy is we say accuracy list at indices 0. All right, but this number is really, 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 really long. So what we can do is we can actually use a library called math. So we'll write here import math, and math has a truncate function that we'll use to make them to ensure that the number doesn't have any decimals. We could also use int, but I just want to show you guys how to actually use this method. All right, so we say math.trunc. This is the argument. All right, and then we string that. An alternative, if we just command Z all of this, is we can literally just do int. We can just say int. All right, and then that's that. All right, we can do int for now. And then what we want to do is we want to create all of this into a string so we can plot it as text and add, actually want to add a percentage. So it looks like 55% or 34%, not just a number. And the last thing we need to do is say font size. All right, so we'll set font size equal to 30. Let's see if what we did actually works. All right, so we're plotting our graph, and now we see that this 1% is here. All right, it's not fully representing the percentage, but just for the viewer or someone watching on TV, when they're seeing stats, they don't want to see 1.38888%. They kind of want to see a concise number. And if you want to fully represent this number, feel free. There are also ways that you can write methods to truncate by a certain amount of decimals. Today we're just representing the number as a percentage, not any numbers after the decimal point. But you can definitely play with that. All right, let me go through and add all the coordinates for the remaining percentages in each shot zone area, and then we'll see our final product. All right, so here are all the coordinate values for all the percentages in each shot zone area. Make sure to take a minute to look at all those coordinates. My code is also going to be posted on GitHub if you guys want to copy and paste certain parts. If you didn't understand how to write it or you didn't catch it, that will also come with comments, the GitHub. So make sure to check that out. The link will also be in the description. All right, so we've plotted we have all the coordinates. We've called on the accuracy list. We set the font size. Now it's time to see our final product. One last thing. We want to make sure and look at our code, make sure we don't have any errors. It looks like we're fine. Hopefully it will run without errors. And there we go. Those are percentages from each part of Kobe's shot zone areas. Make sure to leave a like down below. I hope you guys enjoyed this video. I really had fun playing with this data set. If you guys have any questions, make sure to let me know down below. All right, guys, have a great day. Peace.